Good morning to everyone. This is M. Sudhakar Reddy, Research Scholars, Department of ECE, Wales University, Chennai. So my LS paper is a survey on the battery state of charge and state of health estimation using machine learning and deep learning. Next, abstract. Electric vehicles accurate health evaluation and lifetime prediction of lithium-ion batteries are critical. Early diagnosis of the pure performance allows for the prompt battery system maintenance. In this paper, how the machine learning and deep learning techniques and also algorithms helpful in estimation the state of charge and also state of health of lithium batteries that are utilized in durable electric vehicles. In this paper, in addition, I am explained the basis of the batteries, cells, types of battery along with its characteristics were analyzed and table comprise of techniques used. With state of estimation, either state of charge and also state of health, the metric evaluations calculations by using the machine learning techniques and also deep learning algorithms. Next, what are the objectives in my paper? To estimate the accurate state of charge and state of health of a battery pack, since it is more significant in managing the health and safety of battery packs. To develop the machine learning based algorithms, especially the regression analysis concepts for estimating the battery SOC and SOH. To improve the battery life performance from metric evaluation such as the precision, recall, and F-score and accuracy. Next, problem statement. The most error of the voltage-based SOC happens when the disturbing a battery with a charge or discharge. Accurate estimation of the state of charge remains very complex and it is difficult to implement because battery models are limited and there are the parametric uncertainties. Next, pure accuracy and reliability of the estimation of the state of charge were found by some researchers. To resolve all these issues, we predict the solutions based on machine learning algorithms and also deep learning algorithms to find out the better accuracy and reliability of the state of charge and also state of health. Next, literature survey. So the previous years, the others, the research on the different batteries and he had to use the different algorithms. I will gathering. So this is the literature survey. So the 2020 year, the one of the other had to the research on the lithium ion battery. He used the algorithms, different algorithms, the FNN, RNN, RBF, and SVM. So what is the FNN? Feed forward neural network. Next one is the recurrent neural network and RBF, radial bias function algorithm, and the SVM, support vector machine. So it use the four algorithms. The estimation value is the state of charge and also state of health. The outcome of the paper is the comparison have made in type of the battery, capacity, and temperature. Next other had to use the battery type is the electric vehicles battery. Had to use the algorithm model based adaptive filtering. The estimation of the state of health, the outcome of the paper is that to attain the better accuracy and the feasibility. Next other here research on the lithium ion battery. Use the algorithms of the radial bias function, that is the RBF based neural network. Next, the PSO algorithms. So what are the PSO algorithms? The practical swarm optimization algorithm. So the outcome of the paper is that to handle inconsistency among the cells in battery pack, achieve the high estimation accuracy. Next, author in 2019. Here, research on the lithium-ion battery. Yet use the algorithm is the propagation mechanism. The outcome of the paper is the parameter inconsistency, improve the battery performance. And next, continue. The next author here research on the battery, that is the lithium-ion battery. Here used the two algorithms, that is the hybrid algorithm, Varma and the LSTM. What is that? Varma. So that is the vector auto regression, moving average, and also LSTM algorithm, that is the long short-term memory. Here the estimation, that is the SOC, and the outcome of the paper is the state of charge predicted at multiple cycles, that is the life cycles. Next author in 2019. The battery type is the lithium-ion battery. Here to use the algorithm neural network along with the transfer learning. The estimation is the state of charge. The outcome of the paper is that to improve the state of charge, reduce the training time by the finding the accuracy. Next author in 2020. Here the battery type is the lithium-ion battery. Here to use the LSTM and the NARX neural network based approach. What is the LSTM? That is the long short-term memory, and NARX, that is the non-linear auto regression, that is the neural network based algorithms. The estimation of, that is the state of charge. The outcome of the battery is the accuracy estimation using NN algorithms. So these are the literature survey, my paper. Next, battery management system. This is the main battery management system. Here the three parts. First one is the battery management. Second one is the battery state. Third one is the battery monitoring. In what battery monitoring? Here the data acquisition. So in data acquisition, you have to use the three parameters, that is the current, voltage, and the temperature. So in our battery, have to control by using the thermal management and the safety, that is the data safety, that is the safety production. You have to use the electrical vehicles. This is the main overview of the battery management system. Next, methodology. So in my paper, I had to use the different methodologies. The modules generally followed for our proposed model to estimate the battery state of charge and also state of health are discussed. I have to use the different steps in my methodologies. First one, that is the input, the features extracted from the collected data regarding the battery. Next, output, prediction of state of charge and also state of health value in battery. You have to use the different steps. First one is that define the inputs and outputs. Second, split the data into the training phase and testing phase. Third one is the invoke the inbuilt function for the estimator. Fourth one is the define the Kalman metric function. Next, for different portion of the data, invoke the Kalman metric calculation function. Next one is the estimate state of charge and also state of health value. Next, also display the various other evaluation metrics such as the precision, F-score, and the recall. This is our methodology. Next, so machine learning techniques. Basically, are the three types of the machine learning techniques: supervised, unsupervised, and semi-supervised. So I'm concentrated on the supervised machine learning techniques, especially that is the regression techniques. So the regression techniques are the four types: linear regression, logistic, reads, and the lasso regression techniques. So in the LS paper, we discuss how the machine learning algorithms appropriate in the state of health estimation. So I'm discussed the one of the point here, the SVM approach, that is the support vector machine, and also the dual Kalman filter method. By using the two approaches, that is the state of charge and also state of health on the lithium ion battery, the two approaches were confirmed and the validate via the cell capacity in cycle. That is, they had to increase the life cycle of the battery. Next, in my paper, we discuss the deep learning techniques the suitable in the battery health and the charge estimation. So that is the main important, that is the framework designed by using the hybrid model LSTM RNN for the state of charge prediction. What is the LSTM? Long short-term memory, RNN. And so that is the recurrent neural network. These two algorithms here to use. This is the deep learning techniques. Next, here the reference papers. By using the references, write the literature survey paper. Thank you.